Now for the photoelectric effect, you're going to need the note I gave you. So to learn the photoelectric effect, we first need three frequencies. So let's do this. 1 and 2 and 3 and everybody. 1, 2, 3, 4, 5. Okay. That's the one frequency. 1 and. Every 2 beats would be half a second. So that's 1 second. 1. Okay, let's count it like this. And 1. That's and 2 and 3 and 4 and 5 and 6. Okay, you get the idea. Now let's do it this and stomp. So we go and stomp and 2 and stomp and 3 and stomp and 2 and stomp. So you must stomp with your foot when we say stomp. Okay, so and stomp and 2 and stomp and 2 and stomp and 2 and now, good. Now we've got a slow frequency, which is the stomping. We've got a high frequency, which is this, which is 2 per second. Let's get an intermediate one, which is 1 every second. So we've got 2 hands and 1 foot we've got to use for this. I'm not sure I can do it. I'm not a drummer. So we're going to go and stomp and no, we've got to go. This hand's got to be every second one, okay? And stomp and 2 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 and stomp. Okay, so if and or when physics doesn't work out, you can all become bass drummers, right? So now, we've got a very high frequency. Would anyone like to tell us in hertz? In hertz. Let's start here, read out. In hertz, how many per second is this? Oh, 2 per second. So the frequency is going to be how many hertz? 2 hertz. Okay, and Jamie? And so this one is going and 2. What is the frequency of this one? Nice. So it's got a frequency of 1 per second. It would be written like this. Hertz would be written 1H. No, that's not a 3, that's a Z. Just 1 hertz, 1 beat per second. The first one was 2 hertz. Now let's work out the period. T equals 1 upon F. F equals 2. So what would this one's period be? The period of time between beats for this one. 1 and so this is 1 and 2 and so the period is 1 second. Do you see that? So the period is 1 second. What is the period for this one? Half a second. Now, how would we be able to work it out if we weren't able to? Look out, sit at the back. You come in and you're making a noise. You're disrupting our lesson. Sit at the back. Right? Okay, if we wanted to work out a period, we just go 1 upon whatever that is. 1 upon frequency is period. This would be 1 upon 2, which is a half. You see the frequency is 2, the period is 1 upon frequency, which is equal to 1 upon 2, which is a half a second. Do you see what I'm saying? Now let's do the next one, okay? Let's take the stomp one. And stomp 2, stomping every 4 beats. Taken. Do you know what the frequency of the stomp would be? Would you say the how many stomps per second? Do we have 1 stomp per second or not? We have less than 1 stomp per second. Take a guess. How many stomps do we get? Should we try a quarter? Because the stomp lasts and the stomp is every 2 seconds, isn't it? We have 1 stomp every 2 seconds. So yeah, watch this. There's 1 and 2 and 1 and 2. Only 2 seconds passes between each stomp. I stomp every 2 seconds. Now look at this. If t equals 1 upon f, f equals 1 upon t. So now let's work it out. What is the frequency if the t is 1 stomp every 2 seconds? Does this make sense to you? Does this make sense at all to you, Tony? Let's see if you can work this out. We had 1 stomp every 2 seconds, so what's the frequency of the stomping? 1 every 2 seconds, so what's the frequency of the stomping? What's 1 upon 2, Tony? What is 1 upon 2? Oh. So the frequency is half a hertz. Happy with it? And the period would be, what would the period be, Anna? 2 upon 1. So the period is equal to 2 seconds. That's the length of time it takes for each stomp. All happy? That was a nice bit of revision. So this one would be, would this be a high note or a low note? Yeah, sing us a high note. A high note. Crack the windows for us. Hallelujah! Good try. Okay. So this is the Mikhail, what would the stomp represent? A high or a low note? Sing us a low note. Oh, super. And then what would this one and you come? What does that represent? This intermediate one in Doppler. What does the intermediate note represent? So the high is when it's coming closer, the low is when it's going away, and the middle is when it's standing still or parallel to you. So let's do, can you sing us a middle note? So can we just say super. Okay. Now we understand we've had a little bit of revision on frequency and period. Now we need this for the next thing, which is called the photoelectric effect. The photoelectric effect, the new thing, Sonelli. Are you listening? Okay. So we're going to get the same thing happens with sound as with light. So we get light that's got a high frequency Now tell me, what do you think? Do you think light with a high frequency like sound, do you think it takes a lot of energy to create a high frequency sound, or does it take little energy? A lot. Does that make logical sense? So Nelly, are we chatting about physics? I see we are. Okay. So just as it takes a lot of energy to get your vocal cords to go ee, it takes a lot of energy for light to go the equivalent. Happy with that? So just as a thought, do you think that high energy light is going to give us a sunburn or low energy light? What do you say, Tim? High is going to give us sunburn. Okay. Does everyone know what type of light gives you sunburn? Do you know, for example? Can you tell us what type of light gives us sunburn, which has got the high frequency? What is that protection factor? Protect us against UV. So this represents UV light, high energy light. It's vibrating fast, and the waves are coming off at the same speed of light. So they all travel at the same speed, but they are generated by high or low frequency. Okay, so then, do you know, I don't know if you guys did lighting some standards or other, do you know whether violet is a higher wavelength than red, for example? Do you know the spectrum? Have you seen the spectrum before in grade 10? Would you like to guess maybe? Would you say violet's on the one end of the rainbow and red is on the other? One is high energy, the other's low. Now, just from that previous answer, which end, violet or red, is the higher wavelength? Well, you already said that ultraviolet burns you. So why wouldn't ultraviolet be higher than red? You see the logic? Just let me give you the order. It goes like this. Ultraviolet, violet, indigo, which is a kind of a purple, I believe, I'm colorblind. Then comes blue, then comes green, then comes yellow, then comes orange, then comes red, and then comes infrared. Now that is called the spectrum. It's called the, I forget the, it'll come to me, but that's called the spectrum. You see that violet, they go from high energy to low energy. So this must be very high. Do you see how the wavelengths vary? Make sense? Happy with that? Okay, and then the last question. Think about this. If light hits a metal, now metals like to donate electrons. Which light of those would knock off the electron of the metal, of those violet, indigo, blue, green, yellow, orange, red, ultraviolet, or infrared? Of those wavelengths, which of those would knock off an electron from a metal? Guess. Hang on, let me try. Would a higher energy light knock off, I brought a little photovoltaic cell, when light shines on this, do you think inside here, ultraviolet's going to work better than red, or red's going to work better than ultraviolet light? Come on, we've got to think, guys, critically. Who says red? Hands up. Who says ultraviolet? Do you want the question again? Okay. Light falls of different wavelengths, falls on a photovoltaic panel. Which wavelength of light has got the most energy, therefore will be the best for solar panels? UV, because if it can give you sunburn, it can knock off electrons. Make sense? Make sense? Okay, so I've not really told you anything hopefully too new. Now, what is physics about? Physics is about choosing a formula and plugging in values. Now I can go and retire because I've taught you the secret of physics. Every single problem is taking the formula and plugging in the values. So then, should that make physics easier? Taking a formula and plugging in values. Okay. So let's start here again with us. Have you got your booklets here? Everybody get your booklet and let's go to what is this front page called? BFF. Now I want you to kiss it because it's your best friend. Now let's go and see if we can find the formula for this section. Here is the formula for the photoelectric effect. E equals HF. That is the formula. There's two other minor formulae and they are V equals, what is the formula that we also need for waves? Velocity equals? Frequency times wavelength, and T equals 1 upon F, or F equals 1 upon T. Now those are the only formulas, but this is the one you are going to use. Now we know, if the section has only got basically one formula, do you think it makes it an easy section or a hard section? Easy. Misha? Did Doppler have one formula basically? Two, but not a lot. So if they give you a Doppler problem, you know it's going to use that one formula. It has to, right? Should that make it an easy question? You know you've just got to take that formula and plug in the value. So why doesn't everybody pass physics? That's all you do. Okay, so E equals HF. Would anyone like to guess? I don't want to ask a person a question which they don't know the answer to. What do you think E might stand for? Anybody? Energy. Energy. Okay, so here's the formula. Energy equals H. Now you'll find H on your BFF. It's on page 2. Just find H. It is called what? Okay, Jamie, what is this H called? H is Planck's constant. Okay, and then who do you think Planck was? He was a scientist, probably German. Can you give us the constant? Just read it out for us. Thank you very much. What is it? Give us Planck's constant. Read it out for us. Times 10 to the minus 13, and its unit is joule seconds. Okay, let's say that everybody. 6,63 times 10 to the minus 6. Well, let's just say it, everybody. 6,63 times 10 to the power minus 6. And that is known as Planck's constant. Okay, Tatiana, do you think Planck's constant varies or do you think it doesn't?
It doesn't.
Because it is called a constant. So can we rely on it to stay the same in every problem? Okay. And then we've got F. What do you think, Tatum, F stands for? F stands for? Frequency. So F is frequency. Now we're ready to tackle photoelectric effect. Are we happy, everyone? Okay. Tyrese, do you think that energy is directly or indirectly proportional to frequency? This is like a basic science question which I hope you can answer. And many students can't. If they're both numerators on both sides of an equal sign, is that directly or inversely proportional to that? It is? Lovely. Directly. It means, Anna, the bigger this, the bigger that. And this is a constant. So the only thing that changes energy is the stimulator. The only thing that changes energy here in this formula would be the frequency, because H is a constant. Now, what is the situation? Let's describe the situation. Sun is shining. It means it's vibrating like this. It's sending out waves every time we do it. Right? The wave comes and it hits the little solar panel. Now there's three things that can happen to an electron on this panel. Three things, because we gave you three wavelengths, so that's why, because I'm preparing you to. The first thing it can do is it can knock an electron off. If it knocks an electron off, Mikhail, do you think we get a current or not flowing through the motor of this boat? If it knocks an electron off this panel, there's enough energy to knock it off. Do you think my little boat's motor will turn? There we go. Simple enough. So at this frequency, it will knock the electron off and give it enough energy to spin it. If we had sun, we could show you, but we'll have to wait till a sunnier day. Then there's a second thing that can happen to the electron, which you won't guess, but maybe we'll make you guess. If I have that frequency every 2 seconds, is that a high or a low frequency? Low. So take a guess. Do you think at that low energy or frequency we can knock an electron off? Not enough energy. No turning of our little boat motor. No photoelectric effect at that low frequency. Now anybody, what do you think might happen at the intermediate frequency? So this frequency, what do you think it can do at that frequency? We've got the two extremes. One extreme it knocks an electron off, other it doesn't. What's in between?
So the boats turn slower than the force provided was.
Okay, great. It's a good guess. Let's act out what's going to happen. Okay, let's act it out. You are all electrons. You're sitting on your atoms. Okay. So you're all electrons sitting on your atoms. Now, if I give you a high frequency, this is what I want you to do. I want you to get off your atom and spin around and do some work, and then I want you to sit down again. Okay, so that is what you've got to do. Okay, everybody, are you ready? Okay, I'm giving you a high frequency, so you stand up, spin around, and sit down. Okay, lovely. So you've had enough energy to get up, do some work, and sit down. Come back. Now, I'm going to give you low frequency. Okay, now this is what you do. If I say, yes, sir, that's a low frequency, I want you to just do nothing. Is that easy enough to do nothing? You like doing nothing? Okay. So the electron is not knocked off the electron. But the electron is not knocked off the atom. Happy with that, everybody? Okay. Now, what is the next in-between stage between and I want you to just stand up and don't do any useful work. Just enough energy to get you off your atom, but to do nothing useful. Okay, so I'm going to give you this. Now let's see you stand up and get off your atom. All happy with that? So what is the difference? In one case, you're getting off your atom and doing work. In the second case, you're getting off your atom and doing nothing. In the third case, you're just doing nothing. Great, so that's the photoelectric effect. Does it sound outrageously difficult to you so far? So the intermediate one, you just stand up and do nothing. It's enough to get you off your atom, but to not do any useful work. We can't get a current from it. What will it do? It will not turn the blade. It will not turn the blade, just like if there was no sun. So the energy will, the electron will just get off the atom and do nothing. We will not, the energy is just enough to get off the atom. That's where it rests. Okay, so it had enough energy to pull, to rip the electron off the atom, but not enough to send it anywhere. Okay, now let's finish teaching this section. We call that minimum frequency, we call it the threshold frequency. We call that least amount of frequency to do useful work, we call it F naught. And that is called the threshold, there may be two H's, frequency. Just say that, everybody. So if I've got, I can put there, threshold frequency. Now there's also a special name for when we have F as a naught. It's called not the threshold energy, but it's called the work function. And it's got this name. Work function is HF naught. So W naught is a certain amount of energy, but it's called the work function. And it occurs, it's the amount of energy when F is F naught. All happy? So if I do this, what am I giving you? I'm giving you which frequency? This is above the threshold frequency. This is the threshold frequency. This is below the threshold frequency. Happy with that, everybody? If I give you this frequency, 1 and 2 and 3 and, how much energy do I get? I get work function amount of energy.
So if it's below, it will be negative.
It's just called less than work function or greater than work function. Energy. It hasn't got any specific name. They will just ask, is there enough energy for the work function? And I'm going to show you on this question paper how easy the questions are. They possibly easier than Doppler, but they look complicated because, I don't know, but they're just very easy, these questions. I looked at this question paper, which is last year. Looks easy. Maybe there's something there that might scare me, but so far I'm not scared. Okay. What are we going to do for this period? I've explained, I've basically explained this section, maybe not to your satisfaction, but you've got an introduction to it. Okay, this is what we're going to do for this period. Just listen carefully. Did all of you manage to do those 3 questions of homework? That has to be completed before you go. Now, if you manage to do your homework, how many did all the homework? Just hands up. Well done, you guys. Let's just have a see hands. Well done, well done, well done, well done, well done, well done. Fantastic, fantastic, fantastic. Fantastic. Yeah. I'm going to give you a memo, right? For all the homework, including that last question we didn't quite finish. I'm giving all of you a memo. So if you didn't understand, for example, electrostatics, there's a memo for it. I want you to see it. I want you to study it. I want you to make sure you do understand it. If you don't understand it, this period is for asking. I would recommend, if you don't mind, first ask one of the people who can do it, and then I'll be absolutely happy to come around, but I don't want you to do nothing while you're waiting for me. For the rest of you who have done this homework, in this booklet, you will notice that not only do we give you those exemplar questions, we also have worksheets on them. For example, I see here's question 3, worksheet. Projectile motion worksheet. Can you, while you're in the mood, go and work through the projectile? It covers that same question you've just done for him. You understand what I'm saying? There's one on the electrostatics, which will guide you through the electrostatics. And there's one on the Doppler, and there's one on, what was the other one? Projectile motion, Doppler, electrostatics, and momentum. So can you guys go through that and do that for homework, starting out? What I need to know is, before everyone leaves here, you must have completed the homework, which means even though I give you a memo, if you haven't done it in the book, you must write it out. The same memo that I've given you, so that you get to look at it once. Ask questions about it, and before you leave, I'm going to question you on each of those questions. Also, I want you to take responsibility. If there's something you don't know, like maybe Anna, there's something you don't know, then just stay and ask. Anybody, stay and ask. But I'm going to make sure that if you don't care when you pass, I care. So I must keep you in if you don't understand. Do you understand what I'm saying? So all of you have got something to do. You either completing the worksheet, homework, or you're going through all these worksheets that were the same questions you've done, and then it'll just be like a revision. Presuming you finish that, why don't you have a go at that sheet on, there's a worksheet on the photoelectric effect, so you can go through that as well. I'm going to give you the memo, you're going to do a worksheet on it, then ask me if you still don't understand. Then I'll happily go through it. Or stay afterwards and then I'll explain. Okay, so everyone, you're ready, you know what to do?